Okay, this is the video recording for the memo for the Python script. Before we start, I'd like to mention that I'm using a Spider IDE. It falls under Anaconda and it has Arcpy, um, or you can use Arcpy with it. I prefer using this than using the inbuilt one in ArcGIS, but it's just a preference, so it's not that you need to do it. So to get started, the first things you need to do in order to get this working is import your Arcpy. OS is not necessary, but I used it for getting rid of unnecessary files and stuff like that. So it's not necessary, but you can have it anyway. This one's not needed unless in some cases. I ended up not using it. I was using it and then I removed that ability, so it's not necessary anymore. And then for it's best in practice to set up your input and output as directories so that you can just put these variables into your functions as opposed to needing to put in the entire directory. And then finally, also adding in the output, the out coordinate system that you're going to be using. In this case, if you looked in the flow diagram, you'll see that the WGS 84 EPSG 4326 is the one we're using. Since 4326 is a code, you can put it in directly as a number. You can also use, I'm not sure what the name of it is, but if you go into ArcGIS Pro, you can actually go, when you go and select a coordinate system, you can see both what the code is and what the full string name is. So you can do that as well. If you got the full string name, that works as well, as long as it's the correct string that is associated with that number. Okay. Another good thing to add, this is purely my own preference, but you can add a small comment at the beginning saying who you are. This is a coding technique that is to make sure if your code is ever published that you are credited where you are due. Just make sure if you do this that you aren't copying code directly from online, because that's plagiarism. But if this is your own code, then credit yourself. In this case, it's both myself and Tabiso that worked on this, but there was parts of his code that I did change to integrate with my code. Okay, so the way I usually do my code is I set up functions for it. In this case, I have an initialization function. This initialization function, I do want to mention first is before I do any of these, I set up my environmental workplace as input. You can, of course, do GDB as well, but it means that all your functions will have to also be working with inside the GDB that you might have created. Or yeah, you can use any folder as long as everything you are doing is in line with that. I preferred using input because it's where I was getting all my data from, and it made it easier to only put important stuff in the GDB instead of every single file. And Arcpy env overwrite output helps with. I only saw it actually working with the GDB itself. When I output a file that is the same, it doesn't. It overwrites it instead of adding a new one with a new name. So yeah, back to the functions. For my initialization function, this is what you should do first. Is you can ignore this first part. All this did was remove all files that had that ended with _1. This was just because I was working with when I did a batch of my project of all my files, it created a new one with _1, which is fine. It was easy to denote them. It just means now when I go through it again, it will delete the projected ones and then create new ones. So another thing that I usually do just so you know what's going on with your functions, is I print out, you can either print out when you're starting something, or you can use, I've got it here, this one here, which is print Arcpy get messages, which prints out basically all the status messages that have happened up to that point. So if you pop those through whenever you do a function, at least when you're doing a full, so yeah, whenever you're doing a function, then when you're doing a full function, you will see when these smaller functions happen. Okay, so the first step you do is you create a GDB, um, and then you project your layers to your output coordinate system. You do this as early as possible so that you can then be working with your projected files as opposed to your um, unprojected files, of course. Another one you can do here, though I did much later, was with the slope, the dem, you can also project that as well to the coordinate system. It has a different function, but I'll get to that one later. Doing it now is not a problem. It's the same thing. Just make note of what you called it. Um, okay, and then this is probably the most important thing that I found during this creation of this script, is that when you're working with a large data set, it's highly recommended that you clip your files to the extent that you're going to be working with. Since if you look at the flow diagram, you'll see that you clip to the suitable area only at the end. But I found that it took about 5 hours to do the full script without clipping, or when clipping only at the end. When I clipped the beginning, I found that it only took 20 minutes. And you can see right there how much of an advantage it is to clip at the beginning. So since we are only working with Cape Town, I clipped to Cape Town. You can very easily you can just change the where clause and you'll be able to clip to another city instead. So if we were to change that, you would just be able to change that in here. One thing I do want to make note of is I was using make feature layer management instead of select by attribute and then um, yeah, uh, and then I think it's copy feature management. Yeah, so I was using make feature layer, which does the same thing. It takes in your shape files and it makes a layer of it instead using this restriction. Um, it means that you can then work with a virtual layer instead of a created layer. It means less files, and it also means less problems sometimes. Sometimes select layer by attributes, and even select layer by location doesn't work as well with the script. Um, this is more going into the realm of computer science and how your code reacts with files. But anyway, so yeah, I did this for creating the HP layer, which is the hotspot layer for the city of Cape Town. And then uh, this, the clip, there's no batch clip that I know of. I didn't find one. If you found one, then that's great. Otherwise, the way I did it here is I looped through this created variable, which contains all the shape files that these are all the projected shape files that we'll be using in the future. So it loops through this list and and uses the FC, the feature class within this, and clips it around the extent of the hotspot layer that we created before. This just takes the full name and removes the dot shape. So it's just using the front part. If you do it a different way, that's fine. This is more my way of doing things. And then it just adds the underscore CT dot shape. So it's underscore Cape Town dot shape. Maybe City of Cape Town would have been better, COC, up to you. But I did it that way, just so it's an easier thing to denote. This does mean that your entire file will be, say for instance, land parcels 1 underscore Cape Town. So that's just to take note of. You'll notice here on, say, this function that we're using underscore Cape Town, it just means that now we'll only be working with the extent of Cape Town as opposed to the entire of South Africa. Okay, so that is the clip. Um, I added comments here in the README. This is again something I do personally, just so that if anyone else reads my code, they will understand what's going on. I do, of course, have comments above each of my functions to explain what they do. This is just to explain what the entire function does. So the next thing to do, if you're following the flow diagram, this in this case, you can either do the suitable areas first or the unsuitable areas first. I separated the operations with the function to merge them. So if we go to this one, which is health, river, road operations, that's for the suitable area. That's when we're working with the road, river, and the health sites. So if I go up here to this one, you first make a variable for the file name you're going to be using. It's suggested that you keep the database linking file with you as well, so you know what links to what. In this case, river links to the ZAF water lines DSW1 CT for the projected Cape Town shapefile. Then you perform a buffer analysis around the river buffer. So this is the buffer you are creating of 300 meters. Then you this is to take note of since we have our environmental workplace is input, it means that this river buffer will become a shapefile within the input directory. So doing this here would just mean it would go into the input directory, as opposed to the GDB or whatever. So yeah, this creates the river buffer. Then the next one is for the health site. Again, you create a variable for the health site shapefile, the projected Cape Town. Then you would, as I mentioned before, instead of using select by attributes, I prefer to use make feature layer management. In this case, I'm making a I'm making a health site layer, but I seem to have said HC instead of HS, but whatever. I don't know what I was thinking at the time. It might have been health site Cape Town, but yeah, make sure to denote your layer name based off the feature you're using. I'm not sure what I was thinking at the time there, but anything that makes sense to the people reading it is good enough. So yeah, in this case, you're making a feature layer on the health site, where the amenity is equal to hospital and or the amenity is equal to clinic. Make sure it's or, because we want to include all hospitals and clinics, like or the entirety of both of them, as opposed to only one and the other. We want both. And then copy feature management just takes this layer and creates this shapefile. And then, yeah, mentioned before, I'm going to mention this for the last time, you could instead do select layer by attribute management. It's very similar parameters, and then you do the same here. It would just be with a shapefile as opposed to a layer. Okay, then this is the hospitals and clinics. This is you do a buffer analysis of it of 2000 meters. Then this is a function I made because we are going to be using the road operations twice, once for primary and once for secondary in two different places. So to prevent redundant operations, I created a function for it that takes in the type and the size. So if I go here, you'll see we have road operations, type and size. Here's an explanation of it. So it takes in the projected Cape Town roads shapefile. Again, does the select by attribute, where the class is equal to your type, which in that case is primary. and then it creates a new layer, a new shapefile named the type underscore roads. In this case, would be primary underscore roads. Then it takes in that we just created. This could be unnecessary. You could actually make it anything and then just repeat it here. This just means that if you want to use primary roads in the future, you can use it like that. Anyway, yeah, road type is equal to primary rows in this case. Road buffer will be type underscore buffer, in this case, primary buffer. And then we perform a buffer analysis on the road type, save it in primary buffer in this case. This will all go into the input, and then the size plus meters. In this case, I think it was 500 plus meters. Size is a string. It should work if it was an integer instead, but just to keep things the same, it's preferable that it's a string. Okay, so yeah, that's the road analysis. Then finally, this part here is just adding all these shapefiles that we have created above into the hospital's GDB. Okay, then for the next one, that just to create the unsuitable areas shapefile, this is a different function merely because it makes it easier to separate the operations from the final merge. So with unsuitable areas, that all it does is it does a merge management between all the shapefiles we created and stores it under unsuitable area shapefile in the GDB. Okay, then for the next one, for the suitable areas, very similar to the previous one, we're going to be doing the operations first, which includes the hotspot, the land use, the settlement, the slope, and then we'll be doing the suitable analysis. I will say early that the using the settlements parcels does take a lot of time. There's nothing you can do about this. Even when it's clipped, it still has a lot of pieces, so it will take time. This will probably take the longest time. It's almost preferable to do these functions early so that you don't run into problems where you run out of time, kind of thing. So yeah, so go to this one. This is this one. The first thing you do is you dissolve your so as mentioned before, this is your hotspot layer that you created in your clip, I think. Yeah. So when you create your clip, this is your clipped one. So this is dissolving your hotspot layer into your hospitals and creating it as coronavirus HP by the DC name. So you do this in order to kind of, yeah, or you understand what dissolve does. So this just takes in your layer, the output you want to put it in. Yeah, your layer and the output you want to put it in, and what you want to dissolve by, in this case, the DC name. Okay, then here we are taking in our, I did not make a variable. Actually, wait, this is not my code. I also changed to BSOR's code to be make feature layer management as opposed to select by location, because it took away a lot of code doing it that way. So yeah. Oh, another thing to mention is you can either use this function as arcpy copy features underscore management or arcpy dot management dot copy features. They're both the same function at the end of the day. They have the same parameters and they do the same stuff. So yeah, this is the land use function. So we're going to take in the land use shapefile. We're going to output it as ideal LU, and it's when land use is equal to succulent karoo, grassland, or urban. This is all following the flowchart. It makes it easier to follow the flowchart since it exists. That's the reason why it exists. So you first create a flowchart and then you follow it in your script. Then I did a slope function. This is mainly because this takes so long. So what you can do, instead of running this multiple times, should you need to, instead you run this standalone, and then what you can do with this ID at least, or you can do it in your console, is you can then right click and run this selected thing. So you can run it separately to this. This takes a decent amount of time because a dem is quite big. It's a lot faster now than it was before. Originally I wasn't clipping it, now I am clipping it. With the clipped file, it actually takes a lot faster than previously. Previously, it took about 10 to 15 minutes just to finish it. I'll go into this function now. Slope. Yeah, so slope is your this one. You want to project it to the coordinate system you'll be using underneath the slope rep because you're reprojecting it. Name. Then you're now you've rechanging, so you're changing your variable to slope rep, and you're clipping it to, so the way this works is you're clipping it to no extent, and then you set the extent based off a feature class. That's how this clip works. So if you want, instead of you having an output layer to clip to, sorry, not this one, it's this one. Instead of having an output layer to clip to, you can use an extent instead. In this case, it's preferable to use the layer that you created, as using an extent will give you, I think, a square as opposed to a piece. But I might be wrong. You might be able to do that instead. In this case, it's just easier because we know what this is, that this is the hotspot layer that we are working with. So yeah, that just clips the slope to that area. I'm using this so that in your console you'll be able to see as we go what's going on. So you perform your slope next, which is Arcpy Slope 3D. There is a couple slope tools. This is one that I prefer out of all of them. So you're taking in your slope. This is the slope we created here in our clip management. So it's within City of Cape Town, and then we're outputting it as slope, South Africa slope percentage, because we're using percentage rise. And then, yeah, that will create your slope of your dem under SA slope percentage. Then the next one we're going to reclassify, where under 10% will be 1 and greater than or equal to 10% will equal to 0. So we reclassify the slope percentage using the value, where now this is a string input. So it's between 0 and 9.999 will be 1, and between 10 and 5,000 will be 0. You can, of course, make this a lot higher, but the highest value this will be is only just above 100% for some reason. That would be more of an error, though. I think the maximum will only be 100%, so you can just do that. And this will just classify it as 1 and 0 for the respective things. And then you're outputting it as slope underscore reclass. Okay, and then we're going to vectorize it. So we're going to create a shape file based off this. So you take in your slope reclass, and you want to output it as slope vector. No simplify just makes it so that instead of it basically means that if you wanted to create your dem again, your raster, you can just do a raster to a vector to raster, and you'll have your original stuff. This is a larger file to work with, but it is slightly better. It's more accurate. Simplify basically, I think it smooths the edges, so it makes it look better, I guess. And you're doing it by value. Your value is basically the one that's going to be going through to the feature layer. Okay, so now the next one we're going to be selecting the suitable slope where geogrid code is equal to 1. This is what your numbers, your values became when you created your the reclass. So this function merely takes in your input as slope vector. Um, it's going to create a ideal slope layer where the grid code is equal to 1. So this is all the slopes where it's less than 10% slope. And then you're going to be creating a shapefile that is the ideal slope. Okay, so that was for slope. And then the next one for settlement, you're going to be taking your settlement shapefile and selecting all and creating a layer for the ideal settlement where the SACN type is city, city region, or dense rural. And then you're going to be creating a shapefile for ideal settlement. Then finally, as mentioned before, you can use the road operations under secondary and 100 meters, and it will create the respective secondary buffer shapefile. Here I'm just moving this from the input into the GDB since the rest of these functions are working with the GDB. So then for the suitable areas function, it merely does a merge of all the layers we created previously and puts it into a shapefile of suitable areas. And then finally, the final location function, which makes use of both suitable areas and unsuitable areas in order to make the final location. I was wrong. Sorry. What I mentioned a while ago about the function that will take the longest, it's not the ideal settlements, it is the land parcels. That was an error on my part, and I am sorry. So for final location, you'll be using the land parcels shapefile, which is denoted by LP. We're going to be selecting. Oh no, we're going to be converting all our polylines into a polygon. So currently it's a bunch of polylines. We want to create a polygon instead. So you take in your land parcels and you want to output it as LP underscore polygon. Just make sure the name that you output it as denotes it properly. In this case, it's a polygon as opposed to polylines. And then you're going to be yeah, this merely takes in your shapefile and makes a layer out of it, a virtual layer that you can use. So now we can do a select layer by location, and we're going to be selecting from parcel layer, where it is within the suitable areas. And then you'll be doing a select layer by location remove selection, where you will be finding things within parcel layer parcel layer within the unsuitable areas. So we'll remove all the unsuitable areas from the suitable areas to create your final location. So then you'll be taking that and you'll be copying the features into a shapefile. So we'll take in your this was an error, and I'll fix it in the memo as well. It's meant to be taking in the parcel layer and then outputting as outputting as suitable locations under hospital GDB. That explains a lot. Okay, yeah. So then you can, of course, instead use select by location with just the shapefile, but I prefer using layers. Okay, that should be everything. Your suitable locations will be your final location.